Hey guys, this is Kevin Budachevsky, and this is Disorders of Fructose Metabolism. So how does fructose, a monosaccharide, fit into metabolism? Well, fructose metabolism is important because it converts a substrate for glycolysis into energy production. As you can see, fructose enters the glycolysis pathway at glyceraldehyde 3-phosphate. Normally, it's converted to fructose 1-phosphate by fructokinase in the liver. The enzyme aldolase B then converts fructose 1-phosphate to dihydroacetone phosphate and glyceraldehyde. The enzyme triose kinase can then combine glyceraldehyde and ATP to make G3P, which is one of the important substrates in glycolysis. This is in a normal, healthy patient. So what happens when you're missing key steps in this pathway? Well, essential fructosuria is an autosomal recessive defect in fructokinase. If you're missing fructokinase, what happens? Well, fructokinase is the enzyme that phosphorylates fructose after it enters the cell. And it's this phosphorylation that prevents fructose from crossing the cell membrane and leaving the cell. Therefore, without this enzyme, there's nothing keeping fructose inside of the cell. So how big of a deal would you imagine this would be? Well, there are no nasty metabolites that are building up inside of cells, and fructose can just wash out in the urine. Additionally, there are other more important sources of metabolic fuel, so not surprisingly, this is generally an asymptomatic condition. If you're a mnemonic person, you can think fructokinase is kinder. Will you see large amounts of glucose on urine dipstick in patients with essential fructosuria? No, actually, because the urine dipstick is sensitive for glucose only and not fructose. In these patients, hexokinase becomes the primary pathway converting fructose to F6B. However, fructose intolerance is a more serious autosomal recessive disorder of the enzyme aldolase B. Without aldolase B, fructose 1-phosphate accumulates, and since it's already phosphorylated, it cannot leave the cell. This consumes a lot of available phosphate. So what energy molecule is phosphate an important component of? That's right, ATP, or adenosine triphosphate. Phosphate depletion inhibits glycogenolysis and gluconeogenesis, two processes that require amounts of phosphate to operate. So without glycogenolysis, the breakdown of stored glucose, or gluconeogenesis, which is the formation of new glucose, fructose intolerance can actually cause hypoglycemia, or low blood glucose levels. You'll usually notice symptoms of fructose intolerance after the consumption of fruit, juice, or honey. So what do you think the dipstick will look like in these patients? Well, in fructose intolerance, patients will have detectable amounts of reducing sugars in the urine, but these sugars are again not glucose, so the urine will have a negative dipstick for glucose. In addition to hypoglycemia, the patients will also have jaundice, cirrhosis, and vomiting due to toxic accumulation of fructose 1-phosphate. Again, the important part here is that this cannot leave cells, so causes damage within them. The treatment for this is to not eat fructose or sucrose, since sucrose is a disaccharide composed of fructose and glucose. In general, disorders of galactose metabolism, which we'll discuss in the galactose metabolism videos disorder video, are much more serious. Alright, time for a flash quiz. Is essential fructosuria or fructose intolerance more symptomatic, and why? Well, fructose intolerance is worse since a deficiency in aldolase B leads to a fructose 1-phosphate buildup in cells, reducing available phosphate stores. Again, this inhibits glycogenolysis and gluconeogenesis, leading to hypoglycemia.